Okay, so we have discussed while and do while na loop. For now, we will be discussing the third repetition structure, which is the for loop. Okay, so another loop statement for, which is best for when you can determine in advance how many times you need to execute the loop. Okay, so similar to the while and the do while, um, the for na statement also includes three parts necessary for loops. We have the initialization, the condition or the testing, and as well as the update in order to terminate the loop. So all three loop statements, the while, the do, and the for are functionally equivalent. So here's the syntax of the for loop. So you have the for in a keyword, and inside your parenthesis is the initialization, the condition, and then the update, and inside you have the block of statements. So this is how it works. So we first initialize the statement. So as you can see in the flow chart, it's basically just the same to your while na loop. So you initialize first, and then the condition will be evaluated. Okay, so if the condition is true, the statements inside your inside the loop or inside the loop body will be executed. Okay, after which the loop variable will then be updated, and it will repeat until the condition becomes false. Okay, it will repeat till the condition becomes false. And okay, so as you can see, this is equivalent to your while statement. So yung ano lang dito, yung advantage I think for when you are using the for is that you will never forget the update because you will clearly see na blank pala tong ang third na um, third na part or section ng for after the semicolon. Okay, so both have initialization and then the condition, and then as well as the update, and also of course the block of statements that inside the loop body. Okay, so the for statement is usually best for loops that count up or increment a variable, or count down or decrementing a variable. Okay, so a for statement, there are different variants to the for statement. Okay, so a for statement that counts up or down a total of n times will usually have one of the following forms. Suppose we are counting from 0 to n minus 1. So this will be the for in a loop. So we initialize your I to 0 first, and your condition will be I is less than n. So the loop body will continue executing for as long as your I is still less than n. Okay, so I is less than n is equivalent to n minus 1. Okay, and then the update is I plus plus. So we will increment the I, and then it will this loop will stop executing once your I is equal to I until such time that the I is equal to n. Then another is when we count up from 1 to n. So it means that we will be starting with 1. So we initialize the I with 1, and then the condition will be I is less than or equal to n. So notice the difference here. So we often make a mistake with this one because sometimes we start with 1 and then we use this operator less than. So we are kulang tayo by 1. Or sometimes we start with 0 and then we use this condition I is less than or equal to n. So which means na sumusobra din tayo ng count ng 1. Okay, so we can also count from n minus 1 to 0. So the difference is that we initialize the I starting from n minus 1. And our condition is I should be to 0 daw. So less greater than or equal to 0. And since we are counting down, so we are decrementing the I. Okay. So we can also count from n to 1. So we start initializing, or we start with a value of n for our loop control variable I, and then our condition is that this will continue executing while the I is greater than 0, and then we decrement the I. Okay, so imitating these patterns will help you avoid some of the following errors, which beginning C programmers will often make, and I often make as well. So using less than instead of greater than, or vice versa in the controlling expression or the condition, and then using equals in the controlling expression uh, instead of greater than, or less than equal, greater than equal. So a controlling expression also needs to be true at the beginning of the loop, then later becomes false, so that the loop can terminate. Okay, so then there are also off by one errors, such as writing the controlling expression as I is less than or equal to n instead of I is less than n, as I have mentioned. Okay, so some for loops may not need all three of the expressions that normally control the loop. So that means that you can omit expressions in a for statement, but the semicolon should be there, okay? So if the first expression is omitted, such as this one, so no initialization is performed before the loop. So for example, in here um, we have a for loop that counts down. So it starts from 10, and then it uh, it will count up to 1. Okay. So but in here, the first na statement, or the initialization statement, is blank. Instead, it is put in a separate na line. Okay. So also, if we omit, we can also omit the third na expression. So, and if we omit the third expression in a for statement, the loop body is ensuring that the value of the second expression eventually becomes false. So, remember that the third expression in a for loop is the update. So you have the initialization, the condition, and then the update. Okay, so the different so as you can see, it is blank here, but if without the update, there is no way for the loop to end, to terminate. Okay, so that means that it will result to an infinite loop. So to compensate for omitting the third expression, we've arranged for I to be decremented inside the loop body. So as you can see, we decrement the I inside the loop na body. So since the decrement operator are having side effects, so the I will eventually decrease, will be decremented by 1 at every iteration, until such time that the I becomes 0. Okay, and also we can omit first and third na expressions. So when the first and third expressions are both omitted, the resulting loop is nothing more than a while statement in this, guys. So as you can see, the first statement, which is the initialization, is blank, and we put it on a separate na line. And we should put it before the loop na body, so before the for loop na body. And we also have the third expression, which is omitted. Instead, we put it inside the loop body. So it's very similar to your while. So the initialization is done before. The condition is evaluated before the loop body. And then the update is done is included inside the loop na body. Okay, so but this one is quite unreadable. So the while version is clearer and therefore preferable. Okay. So now, what if the second expression is also missing, aside from the first and the third expression? So if the second expression is missing, it defaults to a true value. So the for statement doesn't terminate unless stopped in some other fashion. So if you use a statement like this with all the three expressions absent, then it will result to an infinite na loop. So let's have an example. So similar to the examples that we've had for the while and the do while na statement. Okay, so we initialize a variable a, which will serve as our loop control na variable, and then our for loop, which has a three expressions separated by semicolon, the initialization, the condition, and then the update. So our condition is that while your a is still less than 6, and then we just continue printing its value. Okay, so let's see. So remember, the initialization takes place only once. So we have here the a is equal to 1, and then it will evaluate the condition. A is less than 6, it is true. So it will print the value of a, which is equal to 1. And now it will proceed to the updating the loop control variable a. So now a becomes 2, and then we evaluate again. So as you can see, we skip the initialization because it's done only once. Now we check 2 is less than 6. It is true. So we print the value of a, and now we increment a. A becomes 3. C is less than 6, which is true. So we print the value of a is equal to 3. And now we increment a. A now becomes 4. 4 is still less than 6. It is true. So it prints the value of a is equal to 3. True. And then we increment a again. A becomes 5. 5 is still less than 6. So it continues to print the value of a. And now we increment a again. A becomes 6, and a is a less than 6. It now becomes false. Okay, so it will end.